All right, on this problem we have a differing angles of motion here, but we know the mass, that's downward, so that's going to be mg, and you know m here, so you're going to want to find what that is. And if we think about our triangles, if you will, we've got this one here at 15 degrees, and it's got a force in the x direction and a force in the y direction, and we're going to call this T1. And so actually let's call this T1x and this T1y. So T1 times the cosine of 15 equals T1x, right? And T1 sine 15 equals T1y. And then on the other side, the 26 degree deal, it'll just be called this T2. So you'll say T2 cos 26 equals T2x, and T2 cos or sine 26 equals T2y. Now, since the only force in the y direction that's applying a force is the weight of the object, you can say that mg, figure out what that is, equals the y's. They have to add up to these two because those forces are pulling the weight opposing gravity. So that's going to be equal to T1 sine 15 plus T2 sine 26. Now the x's are even easier because you've got a force. They have to be balanced because this force is balanced. So you can say that T1 cos 15 equals to T2 cos 26. Now we have an equations, or we have two equations. We have two equations with two unknowns. Unknown 1 is T1, unknown is T2. And at this point, you need to get your algebra skills on and solve this. I am a fan, by the way, of a problem like this. I might just drop it into Desmos, because what you'll get is you'll get two lines, and they'll intersect. And where they intersect will be T1 and T2. You might call this X and this Y. It's supposed to be Y. Call this x and y, and if you just type in the equations as they state, it will draw a graph of those, and where the lines intersect is your answer.